In the previous video we covered some of the basic types in TypeScript, including the number, string, boolean, array, object, and then we also covered some new types to TypeScript such as the enum and also the tuple. So in this video I wanted to go into the more advanced types that TypeScript offers, and this doesn't necessarily mean complex, it just means extended beyond the basic core primitive sort of types that you see in JavaScript and all that. And the first one that I wanted to talk about is the union type. And okay, so what is the union type? Recall in a previous video that we wanted to display an array of strings and numbers and all that sort of stuff. Let's say we wanted to display some text, for example. So I'll create this function called display text, and this will take in some text, and what it will do is it will return the text that gets called. But we may be calling the text in two different ways. For example, we could be calling the function with just the string hello, or we might want to do something a little different with this array of strings. We just want to join it together and separate it with a space. So we know that the text can be either a string or an array of string, and how we can sort of show TypeScript that we could take either a string or an array of strings is just with this vertical line sort of pipe sort of operator, and this is the union type. So union meaning it can be this and this, or it can be that or that, and it accepts both, and we will want to return a string in this case. And something that often occurs in a union type is we say, if the type is a string, do this, otherwise if it's an array of strings, do something else. And that's known as type guarding. So that's another sort of concept, and that can be done in regular JavaScript as well, by the way. But because we're expecting two different types of inputs, if we take the type of the text that's input into the argument, and if that expression is equal to a string, then what we would want to do is we would want to just return the text as is. So we'll just return hello. But if that is not the case, and see this string is erroring because there's no default return state if it's an array of strings. But if it's an array of strings, it doesn't need that first type guard. It'll it'll be the type of the array of strings. We can return the text, and for that array there's an array method called join, and that's just regular TypeScript, and we can join the array strings with a space separated between that. So now if we compile that and we take a look at our document, well, we need to console log it as well. So let's console log that, and I'll put that in there, and I'll put that in the next one. I should delete this as well. I'll just copy that and put that in here. Sorry, in here. Delete this, and I no longer need these. Save that, and we can get hello or hello world. So this is a example of a union type, and I might just type in here type guard. Okay, so after the union type, the next type I want to discuss is the literal type. So let's go ahead and do that. Let's do a Control N to get to the end there. Literal types. So what is a literal type? The literal type means that we can only choose from, there has to be more than one, so there has to be 2 or more values. So for example, if we had a function where we can choose between the colors red, green and blue, and we take a color input, we can literally type in a string literal. So it could be a red string, a green string, or, and this is the union type, the blue. So the literal type is only really effective in combination with the union type. And union type just meaning it can be either or all. And if what we want to do is we want to do a console log, and we want to console log the color. So that function is an example of a literal type, and we're choosing between the string literals as inputs. So if we run red, green, blue function with red, that's okay. But if we put something in here like purple, that will be immediately spotted by TypeScript and will be prompted to sort of, it's not assignable to the type of purple because we've sort of defined this literal type. So let's just go ahead and just say red, do Control Save, and no surprise, we get red. If we were to type in black, we get an error. It still compiles our code, but it just warns us. So TypeScript does compile our code, but it's used to spot. It's up to the developer to change this before it reaches runtime. So yeah, we can just change that back to red, and we can comment this out. So the next thing I want to take a look at is what's known as type aliasing, or a type alias. And this allows us to create our own new type. So if we wanted our own new type, to get a new type, we just use the keyword type, which is known in TypeScript. And let's say we want to do RGB color. We can essentially copy and paste this literal type, but now we've actually, given it, associated the literal type, which is a bunch of string literals, and we've associated it to like an actual type. So we can reuse this literal type. And for example, we can just take that function we had there, copy and paste it, uncomment it, Control /, and rather than having this red, green, blue, we can actually use the type RGB color. So that's a type alias, and that will behave exactly as the previous example. We can also sort of extend that concept, if you will, and let's say we wanted to say make a new type. So we have the RGB colors, and let's say we have a type called stop colors, and it should be noted as before that these have a Pascal case notation whenever we're sort of creating our own sort of things like that, as sort of mentioned in the enum case as well. And we can actually do type aliasing with previous types that we've created as well. So I can actually use this RGB color type alias, which is combination of string, and we can also use the type alias to have black, and then sort of have another union with white as well. So this time, if we were to change this, so I might just comment this out and point one of them out. If I were to change this to stock colors, just press tab for the IntelliSense. It takes all the colors red, green and blue, but it can also take black, which was previously causing an error from before. So that's type aliasing. Now the next thing I wanted to discuss was the null type. I think we missed some of these in the previous video, like null and all that. Undefined. But I might do this in the context of this sort of type aliasing. So we'll create a type role, and let's say that that job can be either a developer or you can be an intern. And we can also do another type alias for salary, which can be a number or null. And you can probably see where this is going. If we write a function called getSalary, which takes a role of the type role, which can be either a developer string or an intern string, we will return a salary type, which will be either a number or null. And then we can just do like a if-else sort of block. So if the role, if that expression equals the string developer, then what we'll do is we will return their salary as $100,000, and we'll just write 100,000. Else return null. So what this is saying is, if you're a developer, you get paid $100,000, but if you're an intern, you're just there for the love of improving. So, and you can see when we console log those functions that we get those different types, different salary types, so either number or null, based on either their input as a developer or intern. So that's just an example of that function, type aliasing and string literals and union types all together in a practical sort of function. But it also explained the keyword null and the type null. In addition to null, a slightly less useful, but still nonetheless a type. So I'll comment this out and say this is null. We'll go on to the undefined type. And undefined, you've seen this in JavaScript as well. So let's just say let undefined variable be of the type undefined. You know, we can't reassign undefined to say 4, for example. That's not a thing. I think this would have pretty rare applications. So if you've got like a niche sort of circumstance, that may be useful. So I won't go into too much more into that. Okay, so we've talked about a few different types. I sort of want to go into like some function overloading. So this will be overloads, and I'll also talk about the void type as well. So this is going to be a practical example. So we're going to imagine the scenario that we've gone shopping and we haven't purchased. We've got our cart of food or trolley, and we want to check out. So we want to create a checkout function, but there's two different scenarios that can happen. So the first is we go to the line in the checkout and we can get immediately served by a customer, by a service operator. So let's just list those checkout operators, and I'll have Jane, Mike, and Zach. So we can either get served by one of these three checkout operators, or we have to wait in line. So for either case, I'll write this function. So there'll be a function get checkout operator, and what we'll do in this circumstance is we need to find the name of one of the we'll just make it a random math function, so we can get the index of the array at random, either 0, 1 or 2, by taking the ceiling of checkout operators. So if we get the length of that, we'll get there's a length of 3. So if we multiply that by math.random, what we're saying here is we can get a number between 1, 2, and 3. Hold on, is that 3? Yeah, we can get a number 1, 2, or 3, and it can be like 1.5, 1.6. But we're taking the ceiling of that, so if we get, say, 1.6 or something like that, they'll round up to 2. And after, but we want one less than that, because recall in JavaScript they're 0 based, and most other languages, by the way. So an array is 0 based, so if we just minus 1 away, we can get either 0, 1, or 2. So this is a way we can sort of randomly generate our operator, and I'll just call that op. And that'll be the index, but to get the actual name, we can take the array and we can take the index that we just randomly generated. And then we will want to call the function here with the input. So we haven't made this function yet, but it's going to be called check out, and it's going to take that, not check out operators, check out, and it's going to take that operator. So it's going to take this string as an input, and then because you've got a check out operator, it's going to do something different. I might just copy the shape of this function here, and I will call this get service time. So get service time, and what this will give back is this function here. So let's just rename, we don't need this line here. We'll want to get a randomly generated service time between, say, 1 and 5 minutes. So let's just say time to service is the ceiling of, and this time we don't need the 0 indexing, so we don't have to minus the 1 away. We can just do that on a random number multiplied by 5, and we'll take the ceiling of that, so the time to service. So in this case we're going to we want to call the same function because we want to perform the same sort of operation, but depending on the situation. If we give it a time, we want to say how long we have to wait until we get a checkout operator, and if we get a checkout operator, we'll randomly get generated a checkout operator. So one thing to note with these sort of method overloading, function overloading, is that we need to go from the most specific to the least specific case. But in this case, we're just taking one variable in. So I think what we can do here is we can just say function checkout. So, okay, function checkout, this is going to be the case that the variable is a string. So this is the get checked out operator case. So if we get an operator, we can get check out, that will be the string case. What is that returning? Well, nothing. And that's the key type that I want to sort of express here, is we're not actually returning anything from the function. And we've seen this before in console logs, and we haven't actually explicitly written it. But if we take a look here and we hover over it, we don't actually need to, because we prefer to just use the TypeScript inference. But this void type means it's not actually returning anything from this particular function. So we can actually explicitly write it's of type void, and that's usually the case when you console log something, or you know, set a variable. But usually if you get something, you will return it, but in this case this get one isn't doing it. So perhaps it wasn't the best naming notation, but it's just the first that came to mind. It's not, it's more to express the void type rather than get into the details of naming conventions. But to continue off on the example, if we get given the X string type as a parameter, meaning that this function was called from here, we also don't really want to return anything. We just want to console log a message. So we'll just say void, and then we'll do the same thing, but in this time the X will be a number, and then we'll console log a message, a different message for that case. And this is like the TypeScript function, writing the type of the function. So a TypeScript function type, most specific to least specific for the function overloading. Now in this last one, this is where we actually write the function itself. So it can be of the type string or the type number, and that's like the union type in action. We can have a string input or a number input. So when we're actually writing the function, we can take in the string or number type. Okay, so we can do some what's it called? Type guarding. So we can do some type guarding, and that's something you often want to do when you've done a union type in a function parameters. So if the type of X equals string and X is a number, then we want to console log something else. We want to console log something else. So if the type is a string, meaning that we have a service operator or a checkout operator, that means we and it can't be a blank operator either. So just to sort of check for that, we can have this AND X sort of thing here. Might be a bit of overkill considering that we randomly generate it, but you know, in other situations you might need that sort of type guarding safety. So I'll just type in CLG console log And I'll write a template literal here, and I'll say that X, so the variable, so you know it's either going to be Jane, Mike, or Zach, is at your service. Cool. Otherwise, that means we've got passed a number, a randomly generated number between 1 and 5. What we can do is we can have another template literal, and we can say, please wait 1 to 5, so 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes. So I'll just say minutes until the checkout operator is available. Cool. So what I want to do is I want to either call this checkout operator function, I might just call it, say, oops, 5 times, and I'll call this get service time, oops, 5 times as well. If I save that, I'm effectively using function overloading, randomly generating either the checkout operator that we got or the service time to get operator. It's going through, it's returning the void type, but it's just outputting this message here like that. So that's like a sort of practical example of function overloading and the void type. Yeah, so that's that. And I might comment these out. I might just delete a few of these. Okay, so what's next? Okay, so we're talking about functions, I suppose. So let's say that we had that add function. Did I write that in this? Oh, I was in a previous video. I'll just quickly write that again. So we'll write this add function, which is an x of a number and a y of the type number, returning a number, and all it's doing is returning x plus y. Okay. Now, let's say we have something, we want a pointer. So we want a pointer to the, so I'll say more function types. So let's say we let the variable add values, and add values can equal to add. So all that is it's a location in memory sort of pointing to this. It's a variable pointing to this location. So it's not executing the function, similar to if you, let's see here, if you do a, like a click event, or event handling, when you click it, you reference the function, you don't call the function, meaning you actually have to click it to do it. It's just pointing to that function, so then if you call it, then it points towards that. Now, in this particular case, we haven't defined any types for this function. So meaning if we say add values equal to anything, so say 5, we can get that pointer, or the property points, the pointer, that will sort of not take into consideration the function type, which requires 2 input numbers and that returns an output number. So how would we sort of, and I suppose before we do that, we might want to take a look at what add values is doing. Let's see here. So just to confirm, if I do add values, say 1 and 2, I save that. Now I get 3 here because what it's doing is this property is referring to this function, or not necessarily, this bit of memory is pointing towards this function, and this function is and we also get that sort of safety there a little bit, but really what we should be doing is calling it a function type. So to do that, we say let add values, and we have this function type here like this. So that means, okay, now if we try and say add values was equal to 4, we get an error because 4 is not a function. It can only point to types that are functions. But this could still potentially point to a function without the right input arguments. So for example, we created a checkout function before. Let's see here. If we sort of get this going again, we save that, and then we put this to check out, that will not error, but obviously it has a different signature. So, and that's erroring because we commented it out. What we should do instead of just saying it's a function, we may want to say what type of function it is. And to do that, and we've sort of seen this before in a sense, but this will sort of clarify the function overloading a little more. So if we make this sort of pointer add values, we can sort of have the function type. So we have the signature of the function, and that's pointing towards the output of the function, and then we sort of terminated the line there. So it's not writing a function, just sort of has the same sort of shape, if you will. So this add values, it takes a number, and this doesn't have to be the same value, but it has to be the same type. So we'll sort of say for the value A, which is X, and the value B, which is Y, of the type number. So that's the signature here of the add function. We're expecting a number output, and that's sort of in this, I'll write this down, function type. That means now that we've sort of defined the type, we can't just say add values is equal to check out, even if we uncomment it like this. And then now add values is erroring, and that's because if we hover over it, it has a different type. Type string, type number void isn't assignable to having two numbers as the input arguments. So this will only work if we have a function with the same signature. So that's a good way we can alleviate any errors. Yeah, so that's function type, and this sort of helps clarify what happened up here when we're doing function overloading. Is okay, so we've sort of declared the shape of the function, but we haven't written out the function, and then we've declared the sort of shape of another function, the same function, but then when we actually write the function, the shape can take either that or that in the argument. So that's functions and some advanced types and some function types. Okay, so the next sort of thing we want to take a look at is a callback function. And you're probably familiar with callback functions from any sort of asynchronous HTTP requests or you know, set timeout or something like that. Just whenever you're making a request to an API, you've got to wait for the response. But we can also have callback functions, so after something is done, then we can perform a function. So I'm going to do a very simple callback function, and we're just going to say hello to the person. So we're going to write this function called greeting, and it's going to take a name, and this is going to be a string, but it might also be null. And the reason it might be null is because the user might enter an empty name on the client side, and we're just assuming that there isn't any validation in place and all that sort of stuff for the extra sort of safety. So what I'm going to do is whatever name gets passed to this function, we're just going to say hello to that name. But I only want to call this function after I've actually retrieved the input from the user. So I need to write another function, askName, and this is going to be a callback function. And this callback function is going to prompt the user. So in JavaScript there's a prompt keyword, so we'll just say const name. So that name is going to be assigned after the user has entered their name. So please enter your name. And yeah, so that's the way the prompt, like it'll be like a pop-up screen will occur on the screen when this askName function is called. And what we want to do is when they enter their name into the prompt window, into the input field, then we want to call this greeting function, but we don't know when that's going to happen. So we have to use this callback function, and so we can say callback name, and what this is doing is once this name variable, you know, is assigned through the front end from them entering into the input, then the callback function will be called, and the callback function that we're putting in is going to be the greeting. So how can we do this? And this will look like this, for example. We call the function askName, and then we have a callback function called greeting, and this greeting function will occur after we've got the name. So it's going to take the name from the input, which, you know, can be string or null, depending if they type anything in or not, and it will just say hello to them. So it should be noted that this function here is returning void, and so we can use type inference as discussed previously. But the main thing that we have to do is we have to fix this error here, the callback type. So we could of course write any, but then, you know, we've already discussed how we've lost lots of value and it's essentially just writing JavaScript, so you might as well just use JavaScript at that point. But to give a type to a callback, where sort of it's very similar to sort of an extension of this function type, where you have the name of the, you know, the value point, or what's it, and it can be of a certain type, and then you get a certain response. So we have a name which is a string or null, and depending, that doesn't matter if they put string or null, we'll still get the void type back. So what we can do is we can say that this callback function, it has a sort of function type where the name entered and this name entered, it doesn't have to be I'm purposely choosing name entered rather than name to sort of separate the greeting function from the callback function. And the name entered can obviously be, it has the same sort of type as the arguments in the greeting function, so that can be a string or null. And if we wanted to, we could say void and return it. This returns a void type. Now in this case we have to have the return void type because we're using the function type, which expects some sort of type in return when sort of written in this sort of way. So with that, if we save that and compile that with a TypeScript compile, we see this pop-up prompt. We enter our name, which is a string, and we click OK, and then it has this other pop-up, which is an alert saying, "Hello, John." Okay, cool. So just to recap the callback function and the function type associated with the callback function, we are asking the user for a name with that prompt box. When they enter their name, this name variable is assigned, and only when it's assigned we can call the callback function with it, and that callback function is sort of passed into this ask name, and we're passing in the greeting callback function. So it takes the name entered, so that's what this callback type is here. This name is, the name entered, just distinguishing between the variable name and the type, so you don't get confused with the greeting name. This name entered here, this just represents the argument basically, so this could say anything, but the key takeaway is that this callback function is taking a string or null type, and it's not actually returning anything from within this function or the greeting function for that matter. So I mean, it is returning an alert box, but that's not in a type. It's not returning data to us in the form of a variable that we'll use elsewhere. So it's returning the void type, and thus when we call that callback function greeting, we're alerting the user, we're saying hello to whatever name they typed in. So that is callback functions. Another sort of type we may have is what's known as unknown. And we've seen the any type, and we've seen how we lose data on the any type, and unknown is just a little bit better than any, but it's something that we also don't use too often. But let's say that we have a username. So let's say we had that prompt box again, and the user needs to input their name, and that's a string, and then we set username equal to John. Well, that's all well and good, but let's say we have something where we don't know what the username is going to be at this stage, So we don't know the type, we don't know it's a string. Like in the previous example, it could have been null, but let's say that it could have been anything because it came from a different location or a different source. We don't know what it is. We can say let input be unknown because we don't know what it's going to be. So this time, if we say, so I might just write this up here so I can uncomment these. This time if I say, you know, username equals input, now this errors because we've said let username be the string. Oh, sorry. Username, let's actually define it. So not a type, but equals. So we've sort of reassigned. Okay, so what we've done is we don't know what the input is, but let's say we had a string. Let's just say we had a string. The username cannot be equal so even if we had an input equals, you know, John, let's say we don't have that at the stage, so whatever input we got, let's say we got a string and then we have this username of the string type, username still can't be assigned to a this unknown type. This type unknown is not assignable to the type string, because even though it is a string and we've assigned it to a string, it might not have been a string. But if we have a look at, if we made this any, that would make the error go away. So it's slightly better than error. It's slightly better than any in that situation where we're not sure, because then we'll get that sort of error in the case that, you know, they passed a number to us and then that wouldn't have been okay. So that's the unknown type, and that's sort of a pretty niche type. And another real niche type is this never type, and you basically, there's not many practical applications of this, but we could imagine that let's just say we have a never ending function, and we can just say we have this while loop of true. Now we'll console log, this will continue forever until it crashes. So the idea of, like, the logic is, like, the programmer's intention for this loop, and it is to just continue to log this message over and over and over again, because true will never terminate. This is very bad because it will eventually crash, but all the data will be allocated and that sort of thing. But in theory, if we had a function of this sort of nature that never ends, there is actually this very sort of bizarre type called never, and it's not really that practical, but it's different to returning nothing. It's different to the void type because it's technically never going to return anything, because void, the function sort of does complete at one stage. And since the function does complete, you know, I might do a console log or something like that, but it still completes. This function never actually runs. Oh, well, it runs, but it never actually ends. So it doesn't actually return anything. And this might be slightly more useful, but very still not really useful. If you have a get error message, so say you throw a new error, and let's say we haven't wrapped this in a try catch block for whatever reason, and it actually crashes the entire application. We don't want this. We don't actually want this function to ever run. We don't actually want it to run, and since we never want it to, even if it does run and there is an error and it crashes our server, our application sort of crash. So because it's crashed, it will never actually completely sort of finish the app. So that's the never type. I still haven't actually found a use case for that, but it's just a type alpha. And I think one of the last things we'll go into is type assertions. So we've talked a lot about all the sort of advanced types and advanced functions, and you know, one of the last sort of beginner sort of TypeScript concepts is type assertions. Oh well, there'll still be interfaces and stuff like that, but in terms of types, so what TypeScript does, it assumes that you as the programmer, you may have more information about a particular situation than TypeScript can deduce from a few lines of code. And it's sort of, type assertions is similar to typecasting in other languages, but it performs no special checking or restructuring of the data. And it should be noted that there's no runtime impact like most of these things. It's just purely used by the compiler to check before runtime errors are evident. And we've seen that in action, but let's just go ahead and let's just say we have some value and it's of the any type, and we say this is a string. And I've purposely chosen the any type, even though we've discussed how we really want to avoid it, because we may have been given this data from, you know, external source, and it could be of any type, and we don't know. It could have been given back as a 5, it could have been as a number, or it could be given back as an array. Doesn't really matter. But let's say we didn't know what it was, but now we're aware of what it is, or we have knowledge of it, and TypeScript doesn't in this case, because when you type in any, you lose all that information. What we can do is, so let's say we want the length of the string, we can say let string length, and that can be a number, and that's going to be equal to, okay, so then we use these sort of square sort of brackets, or not square, these are the angle brackets, and these angle brackets sort of allow us to do the type assertion. So actually I might just write out the variable first. So we could have some value, which is any type, dot length, and before that variable, since we want to sort of convert it or assert the type of it to a number, to a string, we know it's a string, so we can convert the type to a string, which means that and we're getting an error here because we need to wrap these in parentheses so we can assert the type of that particular variable to a string, and then the string method, so now that we know it's a string, TypeScript will give us these, and if we go to L, we can see that we've been given the length, and so with that length property we can get the string length as a number, and that's exactly what we wanted. Now there's two ways we can do this type assertion. We can do it this way. I might just copy that down and comment it out. But we can also do it in another way. So instead of doing the angled brackets, and this is the way I actually more prefer, is doing this sum value, and then we use this as keyword to sort of assert the sum value type as a string. And I definitely prefer this method. I don't know why, I just like the look of it more, and it's completely equivalent. So that's type assertions. So we've covered some advanced sort of not technical, but just more in-depth TypeScript with the union type, the literal types. You know, we've done some undefined, unknowns, nulls, and then we had a look at some function types and some practical sort of overloads and callback functions. We're taking a look at the never type, and then finally type assertion. So we've covered some good ground here, and we're in a pretty good spot. But just we will really need to know about interfaces and maybe some other sort of like perhaps modules and namespacing. But interfaces is a pretty vital part of TypeScript, and we'll cover that in depth in the next video.